6, we were learning how to find values of recursive functions, okay? Today we're going to be taking recursive functions and learning how to see if they have a linear or quadratic relationship. In other words, let me show you what I mean, okay? Well, let's get the heading up here first, okay? Your heading for today is finite differences of recursive functions. Sounds a lot more difficult than it is. It's not that hard. The lesson number is 6.6, and that should say part 2 right there. So be sure and put part 2 in your notes, and be sure and include today's date, okay? Finite differences of recursive functions, lesson 6.6, part 2, and be sure and include today's date. Now, what I'm saying to you is this. Let's say you have a recursive function. You can take notes on this or just watch, and you get out f of 1 equals 3, and then f of 1 equals, or f of 2 equals 5, and then f of 3 equals 6, okay? Well, remember, that's the same thing as an ordered pair. You put in 1, you got out 3, so you only have 1 comma 3, 2 comma 5, 3 comma 6. Well, if you were to line those points up, you would see that you have a linear graph. And actually, that'd be a 7 right here, 3, 7. And you would see that you have a linear graph. So that means that this recursive function has a linear relationship. Now you're probably saying, well, Mr. Aaron, all we have to do is look at the different values and see. That's true, but you have to graph them and look at. There's actually a faster way to do that, using finite differences, and that's what we're going to learn today, okay? So we're going to take some recursive functions, and we're going to decide whether or not they have a linear or quadratic relationship. Now, first, let me say this. If you haven't mastered the material from part 1 of lesson 6.6, you might struggle a little bit, okay? By now, based on the last video we watched, you should be able to find the values of a recursive function. We did that in homework yesterday, or the last time we had homework, you did that, okay? When you are deciding what type of relationship a recursive function has, whether it's linear or quadratic or neither one, you must first find a certain amount of values, okay, of the recursive function. And that's what we learned how to do in part 1 of lesson 6.6. Remember, I would give you a function like this, and I would tell you f of 1 is 3, and then you would find the other 4 or 5 values, remember? Well, you have to know how to do that today before you can start using finite differences. So I really hope you learned the material well from the last video, okay? We are going to use a method today called finding the differences of a recursive function, okay? That's what we're going to do today, and I mentioned that earlier. Let me show you how this is done, okay? And how it helps us decide what type of relationship we have, okay? Let's jump right into this. Here we go. Let's start with this example here. We're going to find the first 7 values of the given recursive function. And then we're going to find the first and second differences. So copy these directions down and listen while you're copying. When I tell you to find the first 7 values, you already know how to do that. In your last video, we usually found the first 5 values. Now we're just going to find the first 7, no big deal. So you know how to do that already. What's going to be new today is you do not know how to find the first and second differences, and I will teach you that in just a couple minutes, okay? So first of all, let's find the first 7 values of the given recursive function, alright? So copy that in your notes like usual. I'm going to move on. So, pause the video or listen while you're copying this down, okay? So we're going to find the first 7 values. Got it? So I'm starting with f of 3. So I'm starting 5, 6, 7. Okay, so I'm starting with 3 because f of 3 equals negative 1. So f of 3 equals negative 1. Now there's a reason in your notes. I would take notes exactly how I'm setting this up. There's a reason I'm going across like this, okay? So f of 3 gave me out what? Negative 1, right? Right there. Now, here's my function right here. I'm going to copy that right here so we can use it. Negative f n minus 1 plus 3, okay? And let's copy that so we can use it over and over. And here we go. Next, we're going to put 4 in for n, so we're going to put 4 in, okay? So bring down your negative sign. Put a 4 right here. What's 4 minus 1? 3. So we have f of 3. We already brought down our negative sign. F of 3 is what? Negative 1. And then bring down your positive 3. So negative 1 is 1. 1 positive 3 is 4. So there we go. F of 4 gave me out 4. Okay? Now let's substitute 5 into the function. Right here. 5. So do you see what I'm doing? We learned this yesterday. I'm just simply finding the first 7 values starting at 3 because that's the value they gave me first, okay? So now I'm going to substitute 5 in for n, okay? So 5 minus 1 is 4. So I have negative f of 4, so bring down your negative sign. F of 4 is 4, so put a 4. Then bring down your positive 3. Negative 4 positive 3 gives you a negative 1. So f of 5 gave me out a negative 1, alright? Let's continue on to the next value. Now we're going to substitute 6 in for n. 6, alright? So we'll put a 6 right here. 6 minus 1 is 5. So I have negative f of 5. Bring down your negative sign. And then f of 5 is negative 1. And then positive 3. So we're going to get out, again, a positive 1. Positive 3. Positive 4. Alright? So f of 6 is 4. And I believe this pattern is going to continue. We'll see if it does, okay? Alright, let's go ahead and substitute 7 in for n now. 7 minus 1 is 6. So I have negative f of 6. Okay? Bring down your negative sign. F of 6 is 4. Bring down your positive 3. Negative 4 positive 3 is negative 1. So f of 7 is negative 1. 2 more to go, alright? Let's substitute 8 in for n now. 8 minus 1 is 7, so I really have f of 7. F of 7. Bring down your negative sign, and then f of 7 is negative 1. And then bring down your positive 3. So negative 1 is positive 1. Positive 3, that's positive 4. So f of 8 is 4, alright? And then lastly, f of 9. We're going to evaluate f of 9. So everywhere there's an n, I'm going to put a 9. So 9 minus 1 is 8. So now I have f of 8. Bring down your negative sign. And then f of 8 is 4. Bring down your positive 3. Combine those and you get a negative 1, okay? So yes or no, did we find our first 7 values? Yes, we did. We started with 3. We went up to 9. We found our first 7 values. So, if we've done the first thing, the first 7 values, now we're going to do this. Are you ready? Here's the new stuff. We're going to find the first and second differences. And it's really, really easy, okay? You start from the left with your values, and you subtract every 2 numbers like this. You take your first number here, negative 1, minus 4. Okay? So negative 1 minus 4 is negative 5. Put that right here. So you subtracted these 2 numbers, and you got this. Now most of you are used to going 4 minus negative 1. That's not how you do it. You start from the left, so you only have negative 1 minus 4. So now we go to the next 2 numbers. 4 minus negative 1. I'm going to circle these. We just did these 2, okay? Now we're going to do these 2 numbers. numbers. Got it? So 4 minus negative 1. 4 minus negative 1 would give you a 5. Put it right in between those two numbers. Now go to the next two numbers. Subtract those two numbers. See how I'm overlapping these two, then these two, then these two. Negative 1 minus 4. We already did that right here. You'll get a negative 5. Now, go to these two numbers. 4 minus a negative 1. 5. Now, negative 1 minus 4. Negative 5. Next, 4 minus a negative 1. 5. So if you'll look what I did, students, very carefully, I wrote the differences. I'll show you in a second. Let me get rid of all these circles. Now, notice how I wrote the differences in between. Like I subtracted these two numbers. I put the 5 right in between it. The negative 5 right in between them. The 5 in between these two, the negative 5. That's how you do it. It's kind of like a pyramid going downward, okay, like this. So, this row right here, this row here is called your what? This row here is called your what? Your first 7 values. Got it? Now it could be 7 values, 5 values, 10 values, 3 values, whatever. Okay? The next row is called your first differences. So make a note of that in your note. First differences. That's what this row here is called. And that makes sense because that's the first numbers you got when you subtracted each number. Alright? Now let's do it again. Do it a second time and that will give you your what? Your second differences. Okay, so here we go. Take these two numbers here. Negative 5 minus 5. That's negative 10. Now take these two numbers. 5 minus a negative 5. That's a positive 10. Now take these two numbers here. Negative 5 minus 5. That's negative 10. Now take these two numbers here. 5 minus a negative 5. That's 10. And now these two numbers here. Negative 5 minus 5. Negative 10. There we go. So this row here would be your first differences. This row here would be your second difference. Now, if I asked you to find the third difference, you would do it again and again and again. Third difference, fourth difference, 15th difference. Or excuse me, fifth difference. Okay. So, this is how you find the first and second differences. Now, Mr. Arrow, you have yet to show us anything that teaches us about linear or quadratic relationships. I'm getting there. I'm laying a foundation. But here's the question you need to ask yourself. Do you know how to find the values? Hopefully you do. From those values, do you see how to find your first differences? From your first differences, do you see how to get your second differences? Okay? I hope you do. Alright, now, let's move on. I'm going to give you another example to work on because I want you to get some practice, okay? But since these types of problems take so much time, I'm going to go ahead and give you the values of the function just to save you. Oh, I'm sorry, excuse me. I'm going to give you the values of the function and just have you find the first, second, and third differences, okay? So here we go. Let me get rid of a couple of circles here because we're going to come back to this later. Okay, here's the function. Go ahead and copy that in your notes if you would, please. And actually, I should have probably written this below, but anyways, here's the given value. F of 0 is 1. And here's the function that we're dealing with, okay? Right there, okay? So what I did, remember, we're starting with 0, right? I'm going to list out the first 7. That's a good number to use, so 0, 1, 2, 3, 4, 5, 6. There's 7 values, okay? And we know f of 0 gives us out 1. Then we'll put 1 in for n, so on and so forth. Now, like I said, to save you time, I've done the work for you. Here it is. You can just copy this down, okay? Because really, you should know how to find the 7 values after yesterday's work, okay? So here it is. There you go, okay? So I guess I could make it a little fancy. This will save us a lot of time in your notes. And you should know how to do this. So I've done all the work for you already. And there's your first 7 values. And by the way, there's no magic number about using 7 values. You don't have to use 7, but it's a good number to use. It gives a pretty good a view of what we're dealing with, okay? Alright, let's go ahead and find the first, second, and third differences, okay? So let's move this over just a little bit. So I've got some room to write over here. And here we go. These are my values. And here's my first differences right here. Okay, I'll put some lines here. Well, maybe I should. Okay, like this. Alright. So we go from left to right. 22 minus 14 is 8. 14 minus 11 is 3. 11 minus 5 is 6. 5 minus 4 is 1. 4 minus 0 is 4. And 0 minus 1 is 1. So there's your first differences right there. Got it? Let's find our second differences now. That's DIFF in case you can't read that. Alright. 8 minus 3 is 5. Okay, students, moving on. Remember, go right to left. If I've been saying left to right, it was just right to left, starting the right, going this way. So 8 minus 3 is 5. 3 minus 6 is negative 3. 6 minus 1 is 5. 1 minus 4 is negative 3. 4 minus 1 is 3. Okay, so there's my second differences. Alright, my second differences. And students, I just found a mistake. You probably noticed it earlier, and I apologize. This should be a negative 1 right here. I thought when I didn't get a 5 here, I thought something was wrong. This should be a negative 1. 4 minus a negative 1 is 5. Okay, there we go. Okay, moving on now to find my third differences. Pretty obvious what to do. 5 minus a negative 3, that's 8. Negative 3 minus 5, that's negative 8. 5 minus a negative 3, that's 8. Negative 3 minus 5, negative 8. Look, students, if you struggle with your signs, use your calculator. Anyone can type this into their calculator. Okay, there's my row, first differences. There's my second differences. There's my third differences, okay? So before we go any further and try to decide whether there's a relationship that's linear or quadratic, I first had to show you how to find these differences. And now that we've done that, now let me explain to you what we're going to do with these, okay? So please take really good notes. Here is how the first and second differences can help us identify if the function is linear or quadratic. I would copy these next sentences, these next two sentences down in your notes. If the first differences are all the same number, not counting 0, they cannot be all zeros, okay? If the first differences are all the same number, not counting 0, then the recursive function is linear. If the second differences are all the same number, not counting 0, so 0 doesn't count, then the recursive function is quadratic. Okay? Now I'm going to ramble while you guys are copying this down. But this is the key right here to today's lesson, right here, these two sentences. If the first differences are all the same number, remember 0 doesn't count, then the recursive function is linear. If the second differences are all the same number, not counting 0, 0 doesn't count. If you get a bunch of zeros, that doesn't count, okay? If the second differences are all the same number, not counting 0, then the recursive function is quadratic, okay? Now if you're not done copying this down, pause the video, I'm going to move on. Let me show you what I mean. Okay, let's go back to our very first problem that we did right here. Okay, so look back in your notes. Look at your first differences. Are every single one of these numbers the same? They're not, are they? So you do not have a linear relationship. Now, pretend for a second you could stop. You would not worry about finding the second difference. You wouldn't care, okay? You would realize all of your first differences are the same number. So you would say, this function right here is linear. In other words, if you were to graph these ordered pairs, you would get a straight line. Now, obviously, that's not true, because remember, I just put the negative signs in, okay? Remember, I just did that. So, we're just pretending all of these were negative, but let's pretend that your first differences did not match. Then go ahead and find the second differences, and let's pretend all of these were negative 10, okay? Well, if that's the case, your second differences are all the same number. So when that happens, you know that you have a quadratic function, okay? So if you were to plot these points and graph it, you would get a parabola, okay? If you plotted enough of them, you'd have to plot enough to get the curve in there, but it would be a parabola. Let's look at the next problem in your notes. Right here, this one. If this first row here would have been all the same number, then you would have had a linear relationship. Let me ask you a question. Were the first differences all the same number here? No. So is this function linear? No, it's not. If your second row is all the same like this, if they were all negative 8, if they were all negative 8, then you would have a quadratic function. Now remember, if they're all zeros, you cannot say you have a quadratic or a linear relationship. Zeros do not count when you're looking to see if all of your numbers are the same, okay? But in this original problem here in your notes, were all of these numbers the same? No, they were not. So this function does not have a quadratic relationship either. So you would say it has neither a linear nor a quadratic. Now we could go on and talk about third differences, which would be cubic functions. Fourth differences, which would be quartic. But we're not into those right now, okay? We're just looking at linear and quadratics, okay? Alright guys, I hope this video's been a help. That's it. I hope you've taken really good notes. I hope that you understand what I'm saying here. You should be able to find the values of a recursive function. From those values, you should be able to find the first differences, and then from the first differences, you should be able to find the second differences, and then from that, you should be able to compare and see if you have